Okay, welcome all to the webinar today. I hope everybody is able to listen to my voice and has a view to my desktop. So today our topic for discussion is inheritance. So anything in case it's not clear or you want to send some message to me, you can put down on the chat window, then we can get it and accordingly we can discuss. So we'll start off with what exactly is inheritance, what things we need to keep track of while inheriting a class, and then method overriding and rest of the issues. If anybody has any problem logging into you can just send us a message or mail, and then we can see how we can resolve to it. So let us see what inheritance is, how we need to inherit a class. I'll just create a simple class. So in case we have a class, say shape, which is a general purpose class that any particular shape can inherit and accordingly provide body to its own methods. Now shape class can have a general method, say void calculate area, and it can have a general method, say void calculate volume. Okay. Now any particular shape, say a class scale, which extends shape, can accordingly use these methods according to its own type. So since it's a scale, and scale requires two properties, say int length, a single dimension is sufficient for a scale, so I'll say int length equal to 10, and then void cal area. We can accordingly use this to calculate. Well, let's say just say a simple method to do this, and accordingly I can put down length into length. Let's say shapes, scales. Okay, maybe a similar name already exists, so we changed this to this is already okay. Now what exactly is inheritance, and when we say that inheritance has happened is, now inheritance, as you can see, the general purpose of the word inheritance is to inherit from somebody. So in this case we are inheriting from a base class which we commonly call as the superclass, and we inherit it into a class we call as a subclass. So in our case, the shapes, it becomes a superclass, and scales which inherits from the shapes class becomes a subclass. So we say inheritance has occurred when the object of subclass, it contains the object of the superclass. So this I can refer to as the object of the superclass. Can have a little bit smaller size. Okay. So this is an object of the superclass. When this is contained within an object of the subclass, we say that inheritance has occurred. So for inheritance to occur, this is one of the conditions that you need to fulfill so that inheritance is the essence of the contract of inheritance is complete. The object of the superclass is contained within the object of the subclass. So what exactly we say when inheritance happens is that everything of the superclass, it becomes a part of the subclass. So even if I have a variable in this superclass, say int x equal to 10, I can access this x through an object of the subclass. I create an object of the subclass and I can access this variable x through the object of scares class, whereas in fact there is no such variable which is declared within scares. So so you can access every part of the superclass through an object of the subclass, and this is the essence of inheritance. Now, when we say this inheritance has occurred, we say that everything that belongs to the superclass now becomes a part of the subclass. So you can access that part through an object of the subclass as if it was a part of the subclass itself. So we are accessing x as if x was declared within this class scares itself. So this is how the essence of inheritance works. And now let us see what essential is the condition for inheritance to be complete. Now as you can see, we have no constructor in class shapes. So when there is no constructor in class shapes, there is a default constructor in class shapes. Now similarly, when there is no constructor in class scares, there is a default constructor in class scares. Now, but since this scares is a subclass, there is an additional code that comes within the default constructor of the subclass, and that is a call to the superclass constructor. Now first of all, we must see why this call is essential, why we need to call the superclass constructor from within the subclass constructor. Now as we have just seen, that inheritance is complete only when the superclass object becomes a part of the subclass object. Now this means that when you create an object of the subclass, when we create an object of the subclass, you need to have an object of the superclass in place. So this is why we need a call to the superclass constructor to be completed before you complete the constructor of the subclass. So as in this case, we did nothing to see such a arrangement is there. This is because by default everything takes place accordingly. Now if I make a small change to this to see if really this is what is happening behind the scenes, is I change this constructor to have some int value. Now immediately the default constructor, or I can just remove this to its original position when there was no constructor in class scares. As you can see, there is an error that comes in this line. It says that it is not able to call the default constructor of the superclass. Since we have defined a constructor in the superclass, there will be no default constructor created for the superclass. So the rule for the constructor, as you might be aware, is in case there is no constructor for a class, in case I comment this code, now we have a default constructor now. So in case there is no constructor that is defined by the user, the system defines a constructor of its own, which we call as the default constructor. So in case you don't define one, there is a system defined default constructor. So if we define our own, there is no default now. We can add a default on our own, but the system will not add any default constructor on its own. But in case of the class scares, what exactly is happening is the default constructor here is calling the default constructor of the superclass. In order to complete the inheritance process, this is calling the superclass constructor, but the call cannot be completed since there is no default constructor in the superclass shapes. So there are two solutions to this. Either we add a default constructor to this and complete the call. I can add a message to this so that you can see how this call process goes. I have a default constructor print within this, and then I can add let me make this out of context. Now we have no constructor within the subclass, and we are creating an object of the subclass. So let us see if this comes into picture anywhere. So as you can see, we have a message which is this is the default constructor. So this statement is being called, means that this constructor is being called by the subclass constructor. There is no object of the superclass that we are creating. We are only creating an object of the subclass. So when we say that inheritance has to occur, we need to have an object of this superclass in place so that the subclass object can be created properly. So the first way is either we create a default constructor for the superclass, or we call up the existing constructor of the superclass with a parameter. So we need to make sure that whenever we create an object of the subclass, we are properly able to invoke the superclass constructor so that the inheritance process is complete. So if we can call a single int constructor, or we can call up the default constructor. So either way, the call to the superclass is complete and our process of inheritance it completes. So the first thing to remember in inheritance is that while you are creating an object of the subclass, the superclass object is in position or is created before the subclass object completes. Second point in this is that this super statement has to be the first statement from the subclass constructor. So in case you want to write some more code to this, or you want to add some call to some method, oh, she is not able to hear. Okay, in case you add any call to any method, say I add a method here, say show, and you put a call to this show before this super. So as you can see, it's not allowing any call before the statement super. So you have to ensure that this call to the superclass constructor is in fact the first statement within the subclass constructor. So now you can give a call to show once you complete a call to the superclass constructor. So next let us see what is method overriding and how does this work. Now we have a method, say cal area, in the shapes class, and we have a cal area within the scares class. So let me get through this, remove this constructors. Okay. So let me put down that this is cal area of shapes. Okay. And this is cal area of scares. Right. Now if I call cal area through an object of scares class, I'll be calling up this method. So this is the cal area of scares. So how do I call the cal area of the superclass from the cal area method of scares? So if I write here cal area, so this will again refer to the cal area which is in scares class. So in case I need to refer to this, I need to add the keyword super here. So this super keyword, it can be used to refer to any variable from the superclass. It can be used to refer to any method from the superclass. In case they are having a clash of names within the two classes. So in case there is an int x here, there is an int x here, and you need to refer to the x from the superclass, then you can refer to that using the super keyword. So now I can have output from the cal area of the scares class, and then it will be calling the cal area from the superclass. Okay, let us see what output this generates. So as you can see, we have a cal area of scares and then we have a cal area of shapes. So same we can use to print x. In case I say we need to add x and you need to add super.x. So you can use the super keyword to refer to any variable from the superclass. In case you don't refer it by super, this will be referring to any variable from the current class. So as we have x is 10, this again 10, so we get here 20. So we have here 20. Another thing to watch out here is that we have a void cal area method in the superclass, and this by inheritance comes down to the subclass. But since the subclass itself declares a same signature method cal area, this method overrides the method from the superclass. So if in case wherever you refer to CAD area in the subclass, it will always refer to the method in the subclass. So this method overrides the method from the superclass. So this we call as the method overriding. Another thing to look for it is anything which is private in the superclass cannot be accessed from within the subclass. So as you can see, the super.x now generates a problem because of the access rules. So any private variable can only be accessed within its own class, and it cannot be accessed beyond its own class even within its subclass. So even though we say that everything from the superclass becomes a part of the subclass, yet the access rules still apply to all variables, all methods. If you declare something private, then it is not accessed from the subclass. So this means in case we have a constructor here and we declare it as private. So what essentially this means is that this constructor cannot be called from any class outside Shapes class. But for inheritance, we just saw that the subclass, it needs to make a call to the superclass constructor, so which in this case is not possible, and therefore inheritance in this case is not possible. So as you can see, so for classes that have private constructors, those cannot be inherited or extended by any other class. So another point in inheritance for Java is that it is a single line inheritance. Now single line inheritance means we have a shapes, I have another class, say scales, and then I can have another class, say color scales. So I can have any number of classes, but these all need to be in a single line hierarchy. So everything from shape gets inherited to scales, everything from scales and shapes is inherited to color scales. So all this happens in a single line. So this essentially means that you cannot have a single class inheriting two classes at the same time. So this is what we used to have in C++, but now we don't have in Java through classes. We cannot inherit two classes at the same time. Means we cannot say class scales extends say shapes or any other say polygons. If there is another class, say, so it cannot extend two classes at the same time. So you can only have a single line inheritance in case of Java. So a class can only inherit a single class at a particular time. Second point in this is that in Java we have a top level class we call as object class. So this is the top level class in Java, and every class must extend from this object class. So as you can see, our shape class seems like a top level class or a super class. But in case we go through this class file of this class shapes, you'll see that this extends this object class. So we'll just see how this is done. So in case I create a simple class, I need to see this on the DOS prompt. So I create a single class, I write class A and nothing in this class A. You just compile this class and then let us disassemble the class file. I'll say java p minus c and then the class name. And now as you can see, class A, it extends java.lang.object, whereas our class A is simply class A. It doesn't extend any other class. But as soon as we compile this class, this automatically extends a class called java.lang.object. So every class, either directly or indirectly, it is extending from this class which is java.lang.object. So this we call as the superclass of all classes in Java. There are some methods in this class that we require in every class. We may need to override them in our own class. As we can see, a simple method called toString. So in case I have my class gears and I print the reference of this object, so I get an output which is this class name, then at the rate, then some memory allocation. So this is the standard way of Java representation for any reference that you print. Now in case you need to print some particular message that this is an object of class shapes, you need to write in a method which is toString. So I'll inherit this. So this is a method that comes from the object class. So I'll write in my own message here, I'll say return, this is an object of class shapes. So what I have done is, earlier the toString method was inherited from the object class into my class shapes. But now since I have created my own toString method, this has overridden the method from the object class. So now for my class, my toString method will be called instead of the default toString method from the superclass. So I will again run this and see what now prints out. So as you can see, this is an object of class shape. So there are many other methods in this object class that we may need in our class to override for some functionality, and we also need this superclass type in many other things for collections and in many other things that we'll shortly see. So let us now see why this overriding becomes so important, and secondly, what essentially are the conditions for method overriding. And the first and the primary condition for method overriding is that you cannot override a static method with a non-static one or a non-static one with a static one. So though both methods need to have the same signature in case they want to override. So either both need to be static or they both need to be non-static. So let us put down both to be non-static. So this is the first condition that we need to see for method overriding. Second is the object casting. How do we do casting in case of objects as we could do in case of data types? Now in case of data types, we have a simple rule that you can pass in any object to a higher type. Int can be assigned to a long, a float can be assigned to a double. So this is a general way of assignment in case of data types. But what in case of object types? So let us see how we can assign object types in Java. This class also. Okay, we have two classes. One is shapes, one is scales. So let us take a simple example. Let's clear this off first. Okay, so let us take an example. I have an object that belongs to a class shape, or I can say it belongs to some class, say A. So this is an object that belongs to a class A, has a variable say X, has a method say show, and we have another object that belongs to a class B. Right. Now this B has inherited from A a variable X, a method show. But on its own, it has added, say, another variable, say Y, another method called show1. So we have a superclass A has a variable X, has a method show. A subclass B has both from the superclass. In addition, it adds on its own a variable as well as a method. So we need to see what works in case A1 is an object for class A and B1 is an object for class B. So whether A1 equal to B1 works or B1 equal to A1 works. So we need to check what assignment is feasible and what works and what does not work. So the first rule that we need to remember for object casting is that the classes in which we need to cast them, suppose A1 is a class A, B1 is for class B, they need to have a relation of inheritance. So in case A and B, they have no relation of inheritance, neither we can do A1 equal to B1 nor we can do B1 equal to A1. So this kind of assignment can only work in case the classes to which A1 and B1 belong, they have a relationship of inheritance. In case there is no relationship of inheritance, these both assignments, they fail. So as if you can see through our code, in case I have a class, say polygons, so just remove this. Not getting it. So I create an object for polygons. So now squares and polygons, they have no relation at all. So this is completely unrelated to this class polygons. So in case I assign SS equal to PP or assign PP equal to SS, they both generate an error. So it says type mismatch. It says type mismatch. So in case both of these classes are totally unrelated, there cannot be any kind of casting between objects of such types. So in order to have these kind of castings, we need a relationship of inheritance. So this altogether we'll have to remove, and I come back to shapes. Okay. So now we'll see what works and what does not work. So we'll go back to our sketch. Now as you can see, if we see A1 equal to B1, let me first see A1 equal to, so A1 equal to B1, this is assigned this object instead of this. So now A1 is an object of class A which requires for its existence a variable x and a method show. Now as you can see, the object of class B has both of them. It has a variable x, it has a method show. So whatever a class or A1 object requires for its consistency or for its declaration, they are all present in the class in the object B1. So this assignment works perfectly. So superclass variable or object, it can refer to a subclass object. So A1 equal to B1 is a perfect uh, viable statement, or is completely consistent with the definition of both the objects. So B1 is an object that contains whatever is desired to be in the object A1. So the system, it allows this kind of casting, and as you can see, if we pass the superclass is shapes, if we pass it an object of the subclass which is scarce, there is absolutely no error. So the first point, it's clear that we can pass in the subclass object to the superclass object. Now let us come down to the second point. When we pass a superclass object to the subclass object, now we assign this to this. Just circle this. Okay. Now B1 is referring to an object which is A1. If we see, the second point, now B1 is referring to an object of class A which is A1. Now B1 requires four things to be its part: a variable x, a method show, a variable y, and a method show 1. So in case all these values are present in this object, this assignment can be a viable statement. But the object A1, it has only two parts. It has a variable x, it has a method show, but it does not have any variable y, nor it has any method show 1. So in the absence of this statement cannot be a viable statement, because we cannot add a variable y, we cannot add a method show 1 to this object to make it compatible with B, with the type B. So B1 equal to A1 is a statement which the system does not allow, since A1 is an object which does not hold the entire data that is required by the object B1 to be consistent with the class B. So any object as B1 is, if belongs to class B, so it needs to have all properties, all methods that are consistent with the definition of class B. Now B has two variables, it has two methods. So in case this object had all these four properties, we would have been able to get this statement through, but since A1 falls short of y and show 1, we are not able to get this statement. So in this case I say SS equal to PP. As you can see, there is an error that says that we cannot convert from shapes to squares. This is because this is a far smaller object, or has far smaller data than what actually is desired by the scarce class. So in a way we can say that the superclass can be assigned a subclass object, but subclass cannot be a superclass object. So this is how object assignment works in case of Java. And now let us see what significance this has, this object assignment, what significance it has in case of method overriding. So if I call cal area for shapes, this calls and returns this is cal area of shapes. If I say cal area for squares, so this says this is cal area of squares. So this prints me this statement. So this is very straightforward. If you print any method for a particular object, it calls the method for that class. For shapes, it calls for shapes. For squares, it calls for squares. So this is where the magic begins. When I assign squares to shapes, my rotate reversal. Shapes is the superclass. We assign its squares, and then I write cal area again. So earlier this was giving me cal area of shapes. So expectedly this will again give me this is cal area of shapes. So let us see what output we get here. So as you can see, first time we get cal area of shapes, absolutely right. Cal area of squares, absolutely right. But this is where the things start to change. We get this is cal area of squares rather than getting this is cal area of shapes. So what exactly happens in this case is a phenomena we call as dynamic method dispatch. Now since this method is there in the subclass, so when this is assigned an object of the subclass, the body of the cal area method is in fact taken from the subclass rather than the superclass. So this is where the method overriding, it gives a phenomena we call as runtime polymorphism. So as you can see, we have the same statement pp.calArea. It gives us an output called this is cal area of shapes, and same pp.calArea now gives this is cal area of squares. So same statement but different result. So this we call as runtime polymorphism. Why runtime? Because the object to which pp is pointing is determined at runtime. So at runtime system checks whether pp refers to which subclass, and accordingly it picks up the body of the method from that very subclass. So this is the how the runtime polymorphism works. This is how the object assignment works in Java, and this is why method overriding is important in Java because of this runtime polymorphism. So another condition for method overriding is that in case you have a method which is public in the superclass, then you cannot have a method package access in the subclass. So this access modifier is important to consider when you have method overriding. So in case it is public in the superclass, then you can have a access modifier which is more open than public, or at least equal to this access modifier in the superclass. Now since public has no more open modifier, so at least you need to specify public here. So in case people who are already working with Java, this is why we need to specify public for every method that we override for an interface, because every method in an interface is by default public. So when you override that method, you need to write the method as public in the overriding class. So many times you forget to put this access modifier as public. Now in case it is package here, then you have an option of package, or you have an option of protected, or you have an option of public. So you got three options in case the method in the superclass is with the access modifier of package. So at least you can have same modifier as the superclass, or you can have a more open access modifier than the superclass. So either I can have a package here, or I can have protected here, which is more open than the package, or I can have public here. So the access modifier has to be more open. Now next point is, if we see, we started off saying that we need to have same signature, either both non-static or both static. So I have now made both methods as static. So let us see what output we get in this case when the methods are static. Now as you can see, for shapes perfectly okay, for squares perfectly okay, but now in case of runtime polymorphism, it is not showing any such phenomena of runtime polymorphism. The output still comes out to be cal area of shapes. We were getting earlier the cal area of squares. Now this is because this runtime polymorphism, it depends upon the type of object that you pass to the variable pp. So in case it is for class squares, the cal area called is for the squares class. But static method, we already know this is independent of the type of object. So since this is independent of the object, it has no effect as to what object you are passing to pp. So it will always call cal area from the class to which this object belongs. So since pp belongs to shapes, it will always call cal area from shapes. So this runtime polymorphism, it does not work for static methods. So in other ways we can say that static methods cannot be overridden. You cannot override a static method. Then we have methods which are final. Now in case a method is final, you cannot override a final method. So as you can see, we are still getting an error for overriding, that you cannot override a final method. Next, in case we declare a class as final, then you cannot override that class. You cannot extend that class. So any class which is final, it cannot be extended and it will remain as a single independent class. So we cannot override any class, extend any class that is final. So next let us see how in a hierarchy of classes, how can we access different variables that get inherited. So let me just remove this all and get some simple classes in place. Say a class A has an index a class B again has an X a class C extends PV again has an X. So in case I have a method show that needs to print all X from all classes. So let us see how we can do that. So just move this all. So to print X from CC, we can simply say X. From BB, if you remember, we can say super.x. And then comes the last and tough part, which is how does it refer to from AA. What we need to do in this case is we need to cast the current object to type A, and then we can print X from. So since this it has inheritance from BB, it has inheritance from A, we need to convert this to the type A, and then we need to print the X. Since all variables are very tightly bound to the class, we get this. Oh, it's already defined. Let's change the names. Just this. So if I simply create an object of this class and I print, so I can get to print X from all three classes. So I have X from 30 from CC, 20 from BB, and 10 from A. So this is how you can refer variables from your upper hierarchy classes. And second, another thing that we just missed out was overriding of variables. So we'll just see if variable overriding happens. So similar to what we did for methods, I'll create an object of class AAA. I'll create an object for class BBB. Assign, let me first print for individual X of A dot X. X of is B dot X. Now if I assign A equal to B, I'm assigning a subclass object to the superclass object that we can do. Now again I write X of A. So now here what we are expecting A dot X, which is 10. B dot X, which we are expecting to be 20. Now this is where we are expecting a different result, A equal to B. As in case of method, what happened was it checked in with the body from the method from the subclass. So in case the same thing happens in case of variables, we'll be getting an output for 20 here. But if we run this, we get an output of 10 here. So there is no method over variable overriding or data overriding. It is only the methods which are overridden, and the variables, since they are more attached to the class, they'll still remain attached to the class. So A dot X will always give you X from the class to which A belongs. B dot X will always give you X from the class to which B belongs. So variables, they are more attached to the class and they will not show the overriding behavior that we saw in case of methods. So this method overriding, the overriding phenomena, it only applies to methods and it does not apply to variables. So this is all we have for this webinar on inheritance. In case anybody has any question, you can put down, we can discuss it. Hello? Hello?
Hello.
Yeah. When were you able, yeah, did you get the sound then?
I got it on another PC.
Okay.
So I just got it.
Okay, do you have any question? We'll be uploading this to the YouTube. You can go through it, and in case you have any question, you can put down to our to our email ID also, 98tech.online@gmail.com. I'll just put down on the chat. Or in case you
Okay.
have anything right now, we can, yeah, we can address it right
No,
now.
sorry, yeah, sorry, I missed, the audio, so I was actually trying to get audio and I just got it on another number, so I just got it here.
No problem. I put on my email ID on the chat window. So we'll
Okay,
put on the video also on the on our YouTube channel. You can go through that. In case still you find something that is not clear to you, you can put on to our email ID. We can reply to you.
okay,
Right,
okay.
right. Thank you. Thank you to everybody who's been on this webinar.